And then we'll get started in a couple minutes. Make sure we allow some time for everybody to be on. Are you talking about my score? My score when I took the FAA written exam was an 82 or 84, something like that. Oh, Lindsay, I'll let her answer that question. What's up, buddy? We got Lindsay, Nick, Pastor Dennis, Raymond, Ray, Sean, Steve, and Stu. We'll give it about one more minute, and then we'll get started. Wow, 1989. That was the year I was born. That's cool. I wonder how different it is. Ray was 3 years old. All right. Well, I think that's good. So we can get started now. Thanks for sharing, you guys. Hope you guys are having a good night. Thanks for being flexible. I know I was on a flight. It came in, scheduled to come in a couple hours before our live, but it was cutting a little too close. So I wanted to reschedule, make sure I could make this, which is a good thing because the flight was delayed and we got home later. So, all right. So one question was Ray. Ray, do you want to, before I start this example, do you want to tell me what exactly you're struggling with? I think you mentioned that you were struggling with like these notes down here, how to implement those. Is that correct? No, you get the notes. Okay. So let me know specific. Okay, there's a specific question. Okay, well, why don't you post that specific question and then I could tackle that. And then meanwhile, while you do that, I will go through this example just so we keep it going. All right, so this is the landing distance chart. I think this is figure 38 of the FAA, knowledge testing supplement. So figure 38, this is what you'll have on your FAA written exam. And the question would be something like this: what is the total landing distance for the following conditions? And so it'll give you, it could give you any sort of different numbers, but in this case, it'll give you, aircraft landing weight, elevation, temperature, runway, come on, runway and wind. And your job is to use the information over here to come up with a landing distance. So best way to explain this is a example. So aircraft weight 1,600 pounds. There's only one option for that. There's only one row. So if this, if this was your actual aircraft, landing performance chart, I assume that it would have more rows for aircraft weight. But on the FAA, they only have the one. And so, and then it's gonna tell, so then we look, okay, so we know we're using this row. And now we have elevation 2,500 feet. So where do we see that at? Well, right here, we're given in these pink sections, we're given an elevation and a temperature. And so we want to find our elevation and temperature. And sometimes it won't be exactly. So this, in this example, 2,500, so we want to use this section right here. We want to use this here, but sometimes it won't be exact, the elevation. And it might say, something like between 2,500 and 5,000. And in that case, you would grab two answers and then interpolate between the two. Or it might be, if it's just ground roll, like this one. So total landing distance, I didn't say over 50-foot obstacle. So when I don't say over 50-foot obstacle, we can assume ground roll. So now we want to check the temperature. So the temperature we're given is 80 degrees Fahrenheit. This says 50 degrees Fahrenheit. So we're like, okay, it's hotter than normal. And if you understand what that means in terms of performance, that means hotter than standard is going to increase your density altitude. Increasing your density and altitude is going to decrease your performance. So that means you're going to increase your landing distance. So, but how do we do that? Well, that's where we come down here and we read these notes. It's really important that on all the charts you read these notes when things aren't quite perfect here in the table. Like now, like this table says 50, we have 80 degrees. So let's look in the notes and see if it tells us something for this. Note 2 says increase the distance by 10% for each 60 degrees Fahrenheit temperature increase above standard. So that's what I was talking about. The distance is going to increase because of the higher temperature, because of the higher density altitude. The density is lower, so aircraft performance is lower. So we have 30 degrees above, right? 80 degrees is 30 degrees above 50 degrees. So this is 10% for each 60 degrees. Well, we're half of 60 degrees, so let's do half of 10% is 5%. So we want to increase it 5%. And what number do we want to increase? Well, again, I said we want total landing distance. I didn't mention it over a 50-foot obstacle, so we want to use this ground roll number. So we want to add 5% to 470. So the best way to do this is to do 470 plus 5% of 470, which is 470 times 0.05. So if I do that, let me get on my phone here. 470 times 0.05 plus 470 is about 493.5. All right, but we're not quite done yet because there's more information that might be of use to us. So it says runway, we're landing on runway 15, so it's in the direction of 150. And I'll get to your guys' questions, don't worry. I just want to try and get these examples for everyone who hasn't gotten to this point yet or who might have questions on the overall process. Where do I get this 0.5 from? Right here? 0.05 or this 0.5? So 0.05. So this is the same thing as 5%. So this is 5% in decimal form. So 5%, percent means per 100. Cent is the word for 100. So 5 per 100, that's 5 per 100. 5 divided by 100 equals 0.05. So that's how you do it mathematically, right? 10% would be 0.1, 20% would be 0.2, 1% would be 0.01. So this is 5%. So when we do 0.05 times 470, right here, we're finding 5% of 470, and then we're adding that to 470 because it said increase. Okay, cool. Yeah, I'm glad you asked that. And I don't want to skip over things that people don't understand, so thank you. Okay, so it says runway 15, and this is the wind is 180 at 10 knots. So, okay, you're looking at this and you're thinking, how will this affect our landing distance? Well, if we're landing, here, if this is runway 15, our wind is going to be from, well, let me draw this actual direction. So runway 15 will be this way. So 115, and we're landing this way. And then the wind is from 18 here. So we're going to have a bit of a headwind. And so how do we calculate? So we're going to want to calculate a headwind because if we, again, look at our notes. So first you want to say, okay, we're going to have some sort of wind in our face. Does that affect landing distance? And that's where your knowledge base needs to kick in and say, okay, yeah, a headwind is going to help us land in a shorter distance. A tailwind would increase our landing distance. And that's what it says right here. It says decrease the distance shown by 10% for each 4 knots of headwind. So let's figure how much headwind we have. There's 2 ways to do that. You can use the FAA chart. It's like a little graph to compute crosswinds and headwinds. I like to use, I'm not going to do that here. We've done that on other lives. If you guys want to see that, I can find the figure. I don't have the figure pulled up on my new computer, but if you want to do that. But I like to use just the trigonometry functions. So to find headwind, you use cosine, and you just do the wind speed, so 10 knots, times cosine of, and the angle between the wind and the runway. So the wind is from 180, and the runway is at 150, so that's a difference of 30 degrees. So then you do 30, and you want to make sure this is degrees when you type this into your calculator, not radians. But if you do that, you can just type this exact thing into Google, and it's going to give you like 8.6, 8.7. So our headwind is 8.7 knots. And then you would get about, you should get about 8.5 to 9 when you do the headwind chart for the FAA figure, which again, we've done in the past. I just wanted to do it quicker here. All right, so we have headwind of about 8.7 knots. Now it says here to decrease the distance shown by 10% for each 4 knots of headwind. Well, we have a little bit over double that. So instead of 10%, we have it for 4 knots, we have 8 knots. So we want to do 20%. So now we want to increase this number, because this is our current landing distance, right? The last thing we calculated, we want to increase that by 20%, or sorry, we want to decrease that by 20%. Why decrease? Because a headwind helps us land in a shorter distance. So this is the distance we want to decrease. So instead of here where we're adding 5%, here we're going to subtract 20%. So 20% would be 0.2. So we multiply 493.5 times 0.2, and that gives us, so this value here is 98.7. And then so we want to subtract 493.5 minus, sorry, that's a bad 5, minus 98.7, so minus 493.5, and that gives us 394.8 or 395 feet. All right, so that's the example. Now let's see what Ray wants us, and if anyone else has any questions, let me know. But that's the general example of how you use this chart and how you use these notes here. All right, so let's see what Ray's got to say for us. The question you get wrong, Ray, is determine the total distance required to land over a 50-foot obstacle. The pressure altitude 3750, headwind 12 knots, temperature standard. Okay, so let me just erase this stuff here, and we'll start with your example now. All right, so pressure altitude is 3750. Okay, so this is exactly what I was talking about. It's not 2,500 and it's not 5,000, it's 3,750. So that's actually right halfway in between 2,500 and 5,000. So we want some value in between right here that we don't have. So we're going to have to interpolate like I was talking about. The question then goes on to say, and again, we're following Ray's questions in the chat, over a 50-foot obstacle. So we want to use these two numbers. So we're going to interpolate between 1135 and 1195. All right. And then it says temperature standard. So that's good because it's just going to say whatever at 3750 feet, the temperature standard. So we don't have to worry about, when it says standard in this case, we don't have to worry about it. We don't have to like add, you know, it's standard. So we don't have to increase the distance by 10% because it's standard. So we don't got to worry about that when it says standard. So that's good. And then it says a headwind is 12 knots. Okay, so first thing we want to do is we want to interpolate between these two values. We want something right here. So this is for 25, hang on a sec. So this is for 2,500 feet. And then this is for 5,000 feet. And we want 3,750, which lies right here in the middle. So we could use the interpolation equation, which I have right over here for this next problem. So we could, if we remember this equation, we could use this equation where our y value that we want would be right here. It would be the landing distance over 50 feet. And then that would make our x value the 3,750. And then x1 would be 2,500, x2 would be this one, y1 would be this, y2 would be this. We could do that, or we can make our lives easier and know that 3,750 is directly between 2,500 and 5,000. And because this is linear interpolation that we're using, we can just easily get the same answer by taking the exact middle between these two numbers. So between 1135 and 1195 is a difference of 60 feet. So if we subtract 1195 minus 1135, we get 60. So then if we take half of 60, so we divide that by 2, we get 30. So halfway between the two is going to be a value of 30. So then we just add 30 to 1135 plus 30. And that gives us 1165. 1165, if you look, whenever you do math like this, you always want to check to make sure it makes sense. So we want 3,750, which is directly between 2,500 and 5,000. We want that corresponding landing distance over a 50-foot obstacle for that. So we want what's directly between 1135 and 1195, and that would be 1165. Does that make sense? Yes, that looks like it's directly in between. It's 30 from 1135 and it's 30 from 1195. So it's right smack dab in the middle. So now we have 1165. Now that we have that number, now we use these notes. So in Ray's problem, it says a 12 knot headwind. So again, we want to use note number 1, which says decrease of distance driven by 10% for each 4 knots. We have 12 knots. So that's 3 times as many knots as 4 knots. So we want to do 3 times as many for this value. So instead of 10%, we want to do 30%. So we're going to decrease 1165 by 30%. And mathematically, 30% is just 0.3. So we want to multiply 1165 by 0.3 and then subtract that number from 1165. 1165 times 0.3 is 349.5 minus 1165 is going to give us 815.5. And that is our answer. So we interpolated first, then we used the notes. You kind of have to do this one step at a time, and you have to interpolate because, again, 3750 is directly between the information that we're given. And we don't have that exact number, so we have to interpolate. All right, can you guys still hear me and see me? It's kind of quiet in the chat, so I just want to make sure I'm not speaking into a void here. Ray, does that make sense? Do you have any follow-up questions? Okay, cool. So Ray, what, just if you don't mind sharing, what were you doing wrong? You know what you were doing wrong. What was it? Oh, you weren't interpreting correctly. Yeah, okay. This video will be on YouTube. I usually keep up these live lessons. I put them on YouTube for about a week or so, and then they disappear because I keep them for our students in our online ground school. So the public can see it for like a week, and then it goes into our bonus downloads and video vault course inside the online ground school. So if you have an online ground school membership, you just go to your bonus course, and then it has all these listed out, all the live lessons we've done. You can watch them, and it's got little labels on it on the stuff we covered. So if you're in the online ground school, you can watch it whenever, but you can watch the replay for a week on YouTube if you're not in the online ground school. Okay, so let's see. Stu had a question here. This is, so I don't know if Melvin is on, but Melvin had a question here on performance. I think it was interpolation. So we just did one interpolation. Maybe we'll do another interpolation equation where we'll actually use the equation and not do the shortcut that I did. Again, we were able to do the shortcut because it was directly in between, so it was really easy. You know, it was 50-50, it was 50% in the middle, right in the middle. So we'll do a little bit different one here. But let me get to Stu's question. Stu says, he wants some clarification on the question on page 127 of your ultimate test prep book. At the top, it asks, refer to figure 52, which type of radar service is provided to VFR aircraft at Lincoln Municipal. My question is regards to figure 52 being the LNK AFD and the other than the R with the circle around it, indicating there are radar services. I don't see a way to determine what specific radar services are available from the info on the AFD. Okay, well, let's see here. Let's pull up figure 52. Give me 1 second to pull that up for you guys so you guys can understand all what we're talking about here. 52. Where is figure 52? Okay, let me. Nope. Come on. Dealing with that PDF can be a pain in the butt sometimes. That Airman Figures PDF. Come on. All right, figure 52. Let me get this here. Copy. Okay, hang tight, guys. I am loading this figure up as we speak so we can all see it here. All right. Okay, so this is an AFD chart supplement for Nebraska, Omaha, or we got Lincoln, sorry, and Loop City Muni. So the question was, refer to figure 52, what type of radar services are provided to VFR aircraft at Lincoln Municipal? My question is in regards to 52 being the LNK AFD and the other than the R with the circle around it, indicating there are radar services. I don't see a way to determine what specific radar services are available from the info in the AFD. Okay. So let's see here. So what I would do is I would, again, just check all these. So you want to look at radar service. So radio aids to navigation here. You have right here, you have a HIWAS, a little H figure in Vortec. What were the option answers? Stu, can you tell us the options, the ABC for that question so we get the full picture? And then I would also look in the airport remarks for any information on radar services. So those are kind of the two places. You want to look down here to radio aids to navigation and, you know, communications. Probably not going to be in communications. So it's talking about here, I believe, and then there might be some information in airport remarks. Airport remarks, I don't see any information there. But yeah, Stu, if you could let us know, I don't have my book on me at the moment. I could go grab one, but yeah, let me know what those are. My guess is it's going to be like, you know, approach departure, and maybe VORTEC, something like that. Okay. Okay, sequencing on the primary Class C airport and standard separation. Sequencing on the primary Class C airport and conflict resolution so that radar targets do not touch. Or 1,000-foot vertical. So sequencing to the primary Class C airport, traffic advisories. Okay. So yeah, it's talking about approach departure control right here. So this is what's going to give you this plus the tower, ground control, and clearance delivery right here. These are going to give you those services. So to know, you have to know, and I'm blanking on it right now. I'd have to look it up in the course, but I believe, so when you have approach and departure, and then you have clearance delivery, you have sequencing to primary Class C airspace and conflict resolution so that radar targets do not touch or without the fish. You have traffic advisory. So I would say, I'm pretty sure the answer would be C. That's what I would go to, but you might be catching me off guard. I'm a little rusty. Your question on that is, other than the R with the circle around it indicating there are radar services, I don't see a way to determine what specific radar services are available. Yeah, okay, so that is how you know. You basically, and this is what I'm blanking on right now, I should know, but the approach departure control and the tower control, tower ground control, and clearance delivery, these each do those functions in the ABC. Okay, so C is the answer. I just don't remember where. Okay, so all right, let me look. I think that's in the online ground school somewhere. If it's not, I should definitely put it because that's a good test question. And I'm guessing it wasn't in the book. So that's a good one. I appreciate you asking that. But yeah, so what basically these are going to tell you. So approach departure control and clearance delivery, they have different functionalities that they provide. They have different services that they provide. And this airport has basically all of them, right? It has ground control, tower control, approach, departure, and clearance. So it's going to have all the functionality and give you all the help, which is answer C. Okay, so let's get to this next example here. Because we had someone in the course, we had Melvin in the course ask about interpolation. So we did one interpolation. So let's do another. And I see that Lindsay, there was another question on the same figure that asked what frequency you would use if you're approaching from the west. Is that a question, Lindsay? Yeah, so Stu's got it. So it tells you right here, these little, tells you the ranges of where you approach them from. So whether you're flying it, you know, that range of headings from the airport, you're going to use the different frequencies. So like Stu said, mind boggler. Yeah, no, it's a good one. And it's a tricky one. So good to ask. All right. Glad I got that one right. You almost had me stumped there. Okay, let's see here. See if you guys can see this. If you have any other questions, you guys put them in the chat while I do this one. But all right, so here is a different sort of very similar chart, but a little bit different, right? This cruise power settings. So we have 3 different sections. We have standard day, we have minus 20 degrees standard and plus 20 degrees standard. And then we have different pressure altitudes. And we have different information in here that we can find if we know the temperature and pressure altitude. So this question says, pressure altitude of 11,500, temperature standard, so we know we're going to use this one, and RPM of 2450. So RPM is 2450 for all of these, so that's kind of silly, but the FAA Written will do this. And then we want 11,500. So right here we have 10,000 and we have 12,000, and we want the fuel consumption rate. So that's going to be fuel flow per engine, gallons per hour. So that's 11.5 or 10.9. Okay, so those are our two values. And we have two pressure altitudes, 10,000 and 12,000, but we want 11,500, which is close to 12,000, closer to this 10.9. So we know our answer is going to be close to that 10.9. But how close? We, again, because it's linear interpolation, we could say, well, 11,500 is 75% of the way from 10,000 to 12,000. So what is 75% of the way from 11.5 to 10.9? You could do something quick. That's the same thing. That logic that you're doing in your brain is the same thing as this interpolation equation. But let's use the equation for this one. And the way I like to do this equation is I like to build a little bit of a table. So I like to build my y values. So I'll, on my scratch paper, I'll just build a little table. Oops. And then I'll start filling it in, and then I'll use the equation. So I think this will be a good way to do this here. All right, so y is what we want. Okay, so that's, this is going to be what we want, and that is a gallons per hour. So question mark G, sorry about that, question mark gallons per hour. So Y1, so we know that Y is our fuel flow, right? So all the Y's are going to be fuel flow. So Y1 is going to be associated with X1, and Y2 is going to be associated with X2. So let's do the first one. Let's do it in this order. So Y1 is going to be 11.5 right here. So let's do 11.5. And that makes X1, if we're going in this order, right here, 10,000. So let's write 10,000 here. Oh, yeah, my mouse is freaking out on me. All right, sorry for this bad, right? All right, then that makes Y2 10.9. And that makes, or sorry, I did this wrong. This is 10,000, X1. I wrote it under X, sorry about that. And then 12,000 is X2. And X corresponds to the Y that we want, is what we're given in the problem, 11,500. All right, so now what we can do is we can put this into the equation. So we have Y equals Y1, which is here, 11.5, plus quantity of X, which is 11,500, minus X1, which is 10,000, and then times this big old fraction here, which is Y2, which is 10.9, minus 11.5, over X2 minus X1. X2 is 12,000, and X1 is 10,000. So now we filled in our equation. Now the next thing we have to know, and this is why I like to avoid the equation when I can and do those type of mental shortcuts that I was showing you in the last one. There's a lot of room for making a mistake. So now what we have to do is we fill this in right, which we did, but now we have to do the orders of operations, which you learned from math class when you were young, hopefully. But if you remember, it's PEMDAS or whatever, so it's parentheses first. So we want to do everything in these parentheses. And so we want to do that first. So let's rewrite this with everything done in the parentheses. So 11,500 minus 10,000 is 1,500. PEMDAS, yeah, that fun stuff. And then 10.9 minus 11.5 is minus 0.6. Right? And then over 12,000 minus 10,000 is 2,000. All right, now the next thing we do, so PEMDAS, P parentheses E exponential, M multiplication, D division, so multiplication and division. So we can do whatever order we want. You can do multiplication first or division first, whatever. Let's do 1,500 times negative 0.6. So 1,500 times negative 0.6 is minus 900. So this now becomes 11.5. Oh, come on, mouse. I need like a pen, one of those pen pads. Oops, sorry. We just did that. So we did 1,500 times negative 0.6. So that's minus 900 over 2,000. All right, now we'll do this division here. So minus 900 divided by 2,000. And then this is plus a minus number, so we can just change this to a minus. So plus a negative number is just a subtraction, so we change this here. And 900 divided by 2,000 is 0.45. So now y equals 11.5 minus 0.45, which is 11.05. So that is the fuel flow rate in gallons per hour for 11,500 feet, which is right between here. So now, does that make sense? I always want you guys to ask yourselves this on the test after you do a bunch of math, especially. We just did all this work. Let's make sure this makes sense. 11,500 is almost all the way to 12,000, right? It's closer to 12,000 than it is to 10,000. In fact, it's 75% of the way there, like we talked about. So 11.05, is it closer to 11.5 or 10.9? It should be closer to 10.9 because, again, 11,500 is closer to 12,000. And it's right. 11.05 is real close to 10.9. So that makes sense to us. So if it didn't make sense, then we might think, oh, maybe we made some errors in our calculations. Yes, there is a faster way to do this. And that's what I did on the last problem. So if I was taking this test, what I would do is I would say, okay, 11,500 is between 12,000 and 10,000. And I would do this in my head, but luckily I can do that in my head, but not everyone can. So that's a difference of 2,000. And then 11,500, right, is, that's 10,000, is 1,500 away. So it's a difference of 1,500 from 10,000, and here it's a difference of 2,000. So then 1,500 divided by 2,000 is 0.75. So it's 75% of the way. So this is the total difference between these two numbers. This is the distance we want between the two numbers, and that is 75% of the way there. So I would then find the difference here, 11.5 minus 10.9. And again, if you can do this in your head, that's what makes it faster. If you can't, then it's essentially, you're just doing the interpolation equation. Minus 10.9 is 0.6. So now you just want to figure out what is 75% of 0.6. So you can do 0.6 times 0.75, and that's 0.45. So now you know you want 0.45 away from 11.5. So you do 11.5 minus 0.45, and that gets you 11.05. Does that make sense? Yeah, by calculating percentages. 11,500 is 75% of the way between 10,000 and 1,200. So you want to find what's 75% of the way between 11.5 and 10.9. That's essentially what I did there. and you find out that 75% of that is 0.45, and 75% of the way there would be this right here, 11.05. Okay. Okie dokie. No problem. Yeah, interpolation is annoying. If you're confident in this sort of mental math and you can do it real quick, I would do it. On a test, I would maybe, go back. If you have time at the end, do the interpolation equation and make sure, check your math if you're not super confident in it. But always, no matter what you do on your math, always ask yourself, does that make sense? Take a step back and say, okay, if there was another entry on this table for 11,500 and my answer sat in here, what was it, 11.05, would that make sense? Does it look like it would fit? So always do that. All right, so any other questions? Yeah, I've always loved math, which is weird. Not a lot of people do, but I actually legit miss taking math classes. That's how weird I am. Anyways. All right, so that we've gone through the two examples I wanted to get to. We answered a couple questions. So Stu, I have the task of looking through the online ground school to see if we have that information there. But basically, what information you're wanting in that question from the book, which type of radar service is provided. Basically, approach, departure, and clearance delivery, those each have give you different services. So that's how which services. And I was able to answer it correctly because it had all of them. So I knew that it had sequencing, it had traffic advisories, conflict resolution, and safety alerts. But if that problem would have been, if it was only approach control, then I would have struggled a little bit on there because I don't remember the exact ones. And I need to look that up and make sure that's in the course. I think it is. I just got to find it. So, but thank you. That was a very good question. Any other questions that you guys have for me? Any other examples you guys want me to do? No? Okay, well, we have a few more minutes. I don't think of what else we could do if there's no other questions. Could maybe quiz you guys on this right here. That could be fun. How about okay, yeah. I'll let you know where it's at. It's definitely somewhere. Stu. But yeah, let's see here. What is this? What is this figure, right? This little symbol right here. There's one here too. Do you guys know what that is on this little map? Stu says windsock. Yep. What about this star? Stu says beacon. Steve says fuel. Ray says beacon. Yeah, it's a beacon. That's where the beacon would be at the airport. What's this? Road, highway, yep. And then this looks to be like train tracks. And then I would say this looks like power lines here. And then I believe this is the information on the fuel. There's like A1, A2, A3, A4, A5, and it tells you what type of services are here. Monorail, yeah, it's the Disneyland monorail. Let's see here. What else? What else can I? What is this number here? 3.0% for runway 17. Yep, glide angle. Yeah, that's the GA glide angle. So for that runway, that is this PAPI. So the PAPI lights, right? You know, where it's going to tell you whether you're on glide slope, above, or below. Well, what is that glide slope? It's a 3-degree angle. So if you have your runway here and you're coming into land, coming into land here, with your aircraft, you want your glide slope on the way down to be 3% to get that perfect light that tells you you're on glide slope from the PAPI. What about this? What about 0.3% up? What's this 0.3% up on runway 32? Lindsay says slope of the runway. And Lindsay is right. Good job, Lindsay. So 3% up. So when you're landing in the direction of 3.2, which is here, is actually a 0.3% like upward slope of the runway. So by the time you get to the end, the elevation is a little bit higher down here than it's here. Not much. They're usually pretty flat, but let's see here. What does this mean? It's for NW. Ray says 4 nautical miles from the city. Lindsay says distance from nearest town or city. So yeah, you guys are right. So it's 4 nautical miles northwest from the nearest big city or whatever. And that will help you at like night, right? Because when you're flying at night, cities are, you know, lit up. You see the street lights, you see the houses, housing lights, and all that stuff. So you can see them lit up on the ground. So you can kind of, it helps you a little bit out at night. You can say, okay, it's for the city. This is 4 nautical miles away from the city. Salma says, how do you verify your glide slope is 3 degrees while you're flying? So that you use the PAPI and the VASI. And then if you're flying like an instrument approach, you can have, you know, more instrumentation that can tell you your glide slope. You know, the more modern your aircraft, the more cool tech you're going to have in there, and it'll be able to tell you your glide slope. But without that, you're going to use these VASIs and PAPIs and the lights on there. So you'll know that the glide slope here, glide angle is 3%. So if you're on glide slope according to the VASI, the lights, which we covered in the last live lesson, we covered VASIs and PAPIs. So if you haven't watched that, go check that out, Sama. And when those lights tell you that you're on glide slope, you know that your glide slope is 3 degrees. With most older aircraft, you're not going to know exactly unless you use the VASI or PAPI. Usually your flight instructor in these older Cessna or Piper Cherokees, they're going to teach you something called sight picture, where you don't have to use your instrument. If your instruments went down, you still want to be able to land the aircraft with the sight picture. Obviously, you need VFR conditions to do that, but private pilot, that's what we can fly in is VFR. But you want to be able to know just by the angle and the position of the nose of your aircraft and the horizon, you should be able to know what the best angle of approach is for your specific aircraft. It changes depending on what aircraft you're in. So you got to get a feel for your aircraft when you fly with your instructor. You got to know trimmed in with the right amount of power and the right amount of pitch trim and the right amount of flap settings. You got to know what that final approach sight picture looks like. You got to get used to that. And once you get used to that, you'll be able to do it without a VASI or PAPI, no problem, because you're so used to it. And that's what makes being the whole pattern of your landing so important, because if you're too high or you're too fast or you have too much power, right? So if you're too high or too fast, you're going to have to start adjusting your power, and you're going to screw up that whole trimmed approach, and it's going to screw up that sight picture and your glide slope on that approach. So that's why it's so important to nail every step of your traffic pattern. Ray says, is there a function on the Sporty's E6B electronic computer to estimate time en route from one airport to another? Yeah, if you know distance and ground speed. So if you know, is that what you're saying? Or so there's a few ways to get time en route. But you have to either know, pulling out my computer right now, my flight computer. So the function for leg time, that'll tell you, what time you have. And I believe that's that input of ground speed and distance. So if you know your ground speed that you're flying and you know the distance from one airport to the other, you can find time. You can also do it if you know your fuel consumption rate, not quite as, usually that value isn't quite as accurate, but if you know your fuel consumption rate and you know the amount of fuel that you consumed, you can backtrack time out as well. But usually you need a ground speed and distance to figure that out. You have to know how fast you traveled over that time, over that distance to get time. Okay. Stu says, I don't think there is a symbol for fuel source. A5 is a type of approach light. Is it really? Did I get that wrong? I'm gonna look that up. Let me know if you guys have any other questions while I look this up. I thought that was something to do with services. Maybe you're right. Maybe it's the type of lighting at the airport. Services is the S values. Yes. So where's the S? S here, right here. S4, that's the services. That tells you the services. Yeah. Good call, Stu. Sorry about that. So yeah, I think you're right. It is the lighting. And that's what the little dot kind of tells you. Yep. Yeah. Good call. All right. Well, if there's no other questions, then I'm going to call it a night. I think it was productive. Thank you guys for joining. As always, you can ask questions in the group, we are next Monday going to try again with the student-led study session. But I think what I'm going to have to do is I'm just going to have to be there for the start of it, which I can do from my phone. So if I'm not home, which like last week, but I think what I did last week, for those of you that tried to get on, is I made it so that the host had to be the one to share or something. There was some weird setting. So basically what will happen is I'll start the meeting, I'll pass it to one of you guys, and then you guys can take it from there and study as you wish. So that should work, and we'll test it out. I'll be there with you guys on Monday to make sure that it goes smooth. But anyways, if you have any questions throughout the week, post it in the group and I'll answer it. And then if not, you can get together with students next Monday at 7 p.m. And then I'll also send out a schedule for the live lessons over the holidays to make sure we're all on the same page on when these are. I'll try to make sure we have something once a week, whether it's a student session or a live session, but we'll have to kind of work around holidays. Yeah, thank you guys. Appreciate it.
Oh, yeah.